Hello, good afternoon. Welcome to this live session of Microwave Engineering. This course is a rerun course, and we are into the sixth week. We have already covered many topics, starting from transmission lines, waveguide, impedance matching, and this week, power dividers, filters. We have also covered different aspects of Smith chart. So I would request the learners who are present here, if they have any query regarding the topics covered so far, you may please ask your queries. Please keep it limited to whatever has been covered so far. So it will be helpful for me to explain if you have any doubt or any clarifications on the topics which have been covered so far. So learners, if you have any queries regarding the topics covered so far in this course, you may please post your queries in the chat box. We are monitoring the chat box and we'll try to answer to your queries. You have already gone through 5 assignments in this course. So if you have any clarification regarding any assignment problems which you have solved so far, that also you can discuss. So dear learners, if you have any query, please let me know. Arun, can you tell me the question, please? I am not right now not having the question with me. Uh, Jagan Kumar, can you please explain more about hybrid Smith chart? You mean to say the Smith chart having impedance and admittance both? Please confirm on the chat. Yeah. Week 4, question number 3. So you have a load impedance with a lambda by 8 transformer. So if you transform it by this lambda by 4 8 line section, then you will get the real part same as Z naught, but you will have a imaginary part which you cancel with the uh, series reactance Jx. I come to the query raised by Mr. Jagan Kumar. Smith chart, normally we plot the impedances. So the admittance point will be, if you draw a line from the impedance point, if you draw a VSW or circle, constant circle, and then drop a line through the center, then where it will hit the circle, that is the admittance point. And similarly, you have R is equal to 1 circle, you can have G is equal to 1 circle. Please note that on a Smith chart, on the horizontal axis, the rightmost point, it represents open, and on the leftmost point, you have a short. And center of the Smith chart is 50 ohm or your normalizing impedance. So accordingly, in some of the Smith charts, along with the constant resistance and constant reactance circle, they provide the plot of the constant conductance and susceptance circle as well. So these charts become useful particularly when you need to switch from switch from impedance to admittance on the same chart. For example, if you consider a shunt stub matching, there you need to use admittance values. So I think we have a worked out example in our lecture video, impedance matching using Smith chart, shunt stub matching, and there you can refer back and you will find the details. Yeah, Anup, good afternoon. Please write your query if you have any. Arun, regarding your query on the question 3, please check when these assignment solutions are shared. If you have any query, even after that, you can send us mail. Either myself or the course TA will respond to your mail. Question number 6 for the assignment week 4. Okay, let me check what is the question. Yes, it is a matching with a series stub. So I hope you remember from the lecture what is a stub. A stub is a short circuited or open circuited transmission line section, which is either connected as a series or a shunt element. Now, if you start from the load impedance and if you move towards the source on a transmission line, the impedance values will keep on changing. And this is what we do. For example, Smith chart gives very nice visualization of the same. If you plot the impedance point on a Smith chart and then if you plot the circle passing through this impedance point with the Smith chart center as the center of the circle, then you get a set of points, or these are the values of the impedances through which it will go through. Now, the real part of the input impedance at some point of time is going to be same as that of the feed characteristic line. But still, you will have a reactive imaginary part present. So since a short circuit or a open circuit stub gives you that imaginary part, admittance or susceptance, suppose you get A plus JB, and to make this real, you will have to add minus JB. So finally, when you start from your load and moves towards the source, and you identify a point where the real part of the input impedance becomes Z0. So at that point, you add a series step. Now at that point, if you have a reactance part, that means say plus Jx, then you will have to connect a stub of appropriate length such that at that point this series stub will give you minus Jx. So length of the, if you remember, if you take a short circuited line, then what you will get? Input impedance is given by Jz0 10 beta L. So from 0 to lambda by 4 length, it will give you a positive, it will give you a reactance because plus Jx of this form. Beyond lambda by 4, it will give you minus Jx of this form. So you need to find out the appropriate length of line as per your requirement. Hope I have answered your query. So Arun, regarding solution part, you will get it later. I think after the assignments are evaluated, then detailed solution is shared at the end. I will talk to our course TA and ask him to share following the policy of NPTEL. So our course TA, Mr. Shashank, he is also present in this session and he's taking a note of your queries and he will do the needful in this regard. Anup, could I clarify your doubts or still you have queries? Any other query, please? Any other query from the learners who are attending? I have not heard from Mr. Anup Pandey whether you are happy with the explanation I have given or you need more detailed discussion on this. Any other, any other learner who is present here in this live session, if you have anything to ask, please ask. So our members from the CT NPTEL team, are there any queries? What are the constraints for doing impedance matching for short open circuited source? Uh, Rectangular antenna output matching. I really am not following your question. Can you elaborate your question a little bit more, please? You are talking of the rectina. Yeah. So please, short open circuited source. Can you please explain your query? Can you please elaborate your query a little bit more? Yeah, I know rectifier antenna is rectangle that I'm aware of, but constants for doing impedance matching for a short open circuited source. Yep. I would request you to please mail your problem details to either myself directly, my email is available, or to the course TA. I'll have to go through it. Okay. Yeah, I understand, but you please share with me your circuit details. I cannot make a general statement. Any other query, please? Once again, I will request you to please restrict your queries to the topics we have covered so far, because this session is meant to give explanation on what has been covered in the lectures. Any other query, please? So no queries on web guides. A double step matching concept. It comes from the fact that many a time the location which comes out as a solution for a step to be attached may not be accessible to you. I think in our video courses, we have solved a step matching problem, double step matching problem. So here, instead of single step, once again, these steps are actually giving you either some reactance or susceptance and can be connected in series or shunt. So you transform first step, connection of first step means you transform the load to another impedance value and then use the second step to complete the matching. You please refer to that section of the video where we have discussed with the problem. So thank you all for joining today's session. I request any other member present in this session to please post your query. So if there are no more queries, I think we can conclude this session. So there was a question, I think, distance between the two staffs are normally kept lambda by 8. Yeah, so this length comes from the sensitivity point of view. If you choose this length, if you take lengths of transmission line which are very close to 0 or very close to lambda by 2, then what happens? The impedance variations become very sensitive. Therefore, lambda by 8 is a comfortable distance. And you can share your email ID. My email ID you can get in my web page. Just type my name, it will take to my web page, and there you will get the details, contact and email ID. So this lambda by 8 part, what you have mentioned, it comes from some practical point of view also, because we want a region where to connect the stub so that it is not a very sensitive function of frequency at that point. Assignment solution कब publish होगा? So that part, I think the TA can answer better. He has already the solutions with him. So you'll have to.
Sir, the detailed solution will be uploaded as soon as possible, sir. The solution is.
Okay.
Yes, sir.
Thank you, Shashank, for this. Shashank, can you please type my email ID in the so that people can get it?
Okay, sir. I'm going to provide.
Okay. Any other queries, please? So Shashank is providing the email ID. I would request Mr. Perumal to please share with me the circuit he was talking. I'll have to look at the circuit configuration of the Rectena to answer your query properly. Any more queries, please? So if not, can we close this session? NPTEL team, please let me know whether we should continue or close it now, because I'm not getting any more. Okay, so please close the session. Thank you.